Hello dear students. Now today we are going to see the another device, that is Mosfet. Mosfet is nothing but metal oxide semiconductor field effect transistor. It is a unipolar transistor and is used as an electronic switch to amplify electronic signals. It is a semiconductor device which is widely used for switching purposes and for the amplification of electronic signals in electronic devices. A MOSFET is either a core or integrated circuit where it is designed and fabricated in a single chip because the device is available in very small sizes. It is available in two basic forms. One is the depletion type, another is a enhancement type. In depletion type, the transistor requires the gate source voltage to switch the device off. The depletion mode MOSFET is equivalent to a normally closed switch. Enhancement type. The transistor requires a gate source voltage to switch the device on. So, the enhancement mode MOSFET is equivalent to a normally open switch. MOSFET has three terminals consisting of a source, gate, and drain. Besides these terminals, there is a substrate. Substrate word is nothing but a body. There is a substrate which is called as substrate, body which is called as substrate. The substrate, generally called body, is always connected to source terminal. A MOSFET can function in two ways: depletion mode, enhancement mode. Here you can see the structural view of MOSFET and how physically it looks like. Here you can see the three terminals: gate, source, and drain. It is fabricated by the oxidation of silicon. It works by means by changing alternately the width of the channel through which the movement of charge carriers, that is electrons for N channel and holes for P channel, occurs from source to drain. The gate terminal is insulated, whose voltage regulates the conductivity of MOSFET. The types of MOSFET, as told earlier, there are basically two types. One is the depletion type and enhancement type. So, depletion type is again categorized into two: depletion mode N channel and depletion mode P channel. So also enhancement type categorized into enhancement mode N channel, enhancement mode P channel. Now what is it? In enhancement type MOSFET, there is no conduction at zero voltage, so it is off. Understood? The gate voltage is directly proportional to the current. The meaning of this is that as the gate voltage increases, the current will also increase, and as the gate voltage decreases, the current also decreases. The types of enhancement mode are depending upon the body, which is doping of the body, whether it is N type or P type. So N channel enhancement type MOSFET, P channel enhancement type MOSFET. Now this is the structure of N channel enhancement type MOSFET. Here you can see the doping source gate terminal, the doping of the body, dope region N type and P type substrate body. A lightly doped p-type substrate body forms the body of the device, and the source and drain are heavily doped with n-type impurities. N-channel have electrons as majority carriers. The applied gate voltage is positive to turn on the Mosfet. Here the P channel, here you can see the body is of N type and the doping is of P type. So a lightly doped N type substrate body forms the body of the device, and the source and drain are heavily doped with P type impurities. P channel have holes as majority carriers. Now see the difference. P channel have holes as majority carriers and N channel have electrons as majority carriers. The applied gate voltage is negative to turn on the Mosfet. Now the depletion type Mosfet. In this type, the channel is already established and conduction occurs even at zero voltage, and it is open or on by default. The types of depletion MOSFET: N channel depletion type MOSFET, P channel depletion type MOSFET. Now here N channel depletion type MOSFET. N channel depletion type MOSFET, in this you can see the body is of P layer, P type. The p-type semiconductor forms the body, and the source and drain are heavily doped with n-type impurities. The applied gate voltage is negative and the channel is depleted of its free electrons. Now here you can see p-channel depletion type MOSFET. Here you can see the body is of n-type and the dope region is of p-type connected to source and drain terminals. The n-type semiconductor forms the substrate, that is body, and the source and drain are heavily doped with n-type impurities. The applied gate voltage is positive and the channel is depleted of its free holes. Sorry, here the channel is depleted with p-type impurities. Now, the symbols of different types of MOSFETs. Here you can see the symbols of different types of MOSFET. First one is the N-channel enhancement type symbol, N-channel depletion type symbol, P-channel enhancement type symbol, P-channel depletion type symbol. Applications of MOSFET. MOSFET are generally used in radio frequency applications. It acts as a passive element like resistor, capacitor, and inductor. The DC motors can be regulated by power MOSFETs. High switching speed of MOSFETs make it an ideal choice in designing chopper circuits. What is chopper circuit? We will be studying in nearby lectures. Advantages of MOSFETs. MOSFET provide greater efficiency by operating at lower voltages. Absence of gate current will result in high input impedance, producing high switching speed. They operate at low power and draws no current. The disadvantages of MOSFET. The thin oxide layer make the MOSFETs very transparent it is and very thin, so there may be a possibility that when it is exposed to or exposed by electrostatic charges, then there may be a possibility that the MOSFET may damage permanently. The another disadvantage is that the overload voltage will make the MOSFET unstable. So this was all about the MOSFET. I hope you all have understood this. Keep learning, stay safe, stay healthy. Thank you.